The rise of 3D printing has taken the manufacturing world by storm. It allows us to create physical objects directly from digital models. This technology, also known as additive manufacturing, builds objects layer by layer. It uses materials like plastics, metals, and even composites. 3D printing has opened up a world of possibilities for designers and engineers. We can now rapidly prototype designs. We can create complex geometries that were previously impossible. 3D printing allows for incredible customization and on-demand manufacturing. But with all its advantages, it's important to remember that 3D printing is a tool. It's not a magic solution that replaces all traditional manufacturing processes. While 3D printing excels in creating physical forms, it often falls short in conveying critical engineering information. 3D models are excellent for visualizing shapes and designs, but they often lack the detailed specifications needed for functional, manufacturable parts. A 3D model might show us the overall form of a gear. However, it won't necessarily tell us the required material hardness for wear resistance. Similarly, the model alone can't convey the acceptable tolerances for the gear teeth. These tolerances are critical for ensuring smooth meshing and proper functionality. Without this information, the 3D printed part might look right, but fail to perform as intended. This is where the importance of detailed engineering drawings becomes clear. Engineering drawings are the language engineers use to communicate their designs with precision and clarity. These drawings are not just simple sketches. They are detailed blueprints that convey every aspect of a design. They provide a level of detail that 3D models alone cannot match. While 3D models offer a visual representation, engineering drawings break down the specifics. Drawings include crucial information about a part's dimensions, tolerances, materials, and surface finishes. This information is vital for manufacturing and quality control. They utilize a standardized system of symbols and annotations. These symbols are universally recognized, ensuring consistency across different teams and industries. This ensures that everyone involved in the manufacturing process understands the design intent. Clear communication is key to successful project execution. One of the most important aspects of engineering drawings is geometric dimensioning and tolerancing, or GD and T. GD and T provides a comprehensive framework for defining the geometry of parts. GD and T goes beyond basic dimensions. It specifies the allowable variations in form, orientation, and location of features. It defines the relationship between features on a part. This ensures that parts will fit together as intended, even with minor deviations. It establishes acceptable deviations from the ideal geometry. These tolerance zones are critical for maintaining functionality and performance. This level of precision is essential for ensuring parts fit together correctly and function reliably. Without such detailed drawings, achieving the desired quality and performance would be challenging. In manufacturing, consistency is key. Without it, the entire production process can fall apart, leading to inefficiencies and increased costs. Engineering drawings play a vital role in achieving repeatable quality. These detailed blueprints serve as the foundation for the entire manufacturing process. By clearly defining all aspects of a part's design, drawings eliminate ambiguity and reduce the potential for errors. Every dimension, tolerance, and material specification is meticulously outlined. When a manufacturer receives a set of detailed drawings, they have a clear roadmap for producing the part. This roadmap ensures that every step of the production process is followed precisely. This ensures that every part meets the specified requirements, regardless of who is making it or where it's being made. Consistency in production leads to higher quality products and customer satisfaction. This level of control is essential for maintaining quality standards and minimizing variations between parts. It allows manufacturers to produce parts that are virtually identical, batch after batch. It also allows for easier troubleshooting and quality control. When issues arise, having detailed drawings makes it simpler to pinpoint the problem. If a problem arises during production, engineers can refer to the drawings to identify the source of the issue and implement corrective actions. This systematic approach ensures that any deviations are quickly corrected, maintaining the integrity of the production process. Section 5. Communication is key drawings as a universal language. Engineering drawings serve as a universal language in the world of manufacturing. They allow engineers, machinists, quality inspectors, and suppliers to communicate effectively. Regardless of their location or language, everyone involved in the process can understand the design intent and manufacturing requirements. This shared understanding is essential for successful collaboration and efficient production. Drawings facilitate clear communication, minimize misinterpretations, and reduce the risk of costly errors. They act as a single source of truth for all stakeholders, ensuring everyone is working from the same playbook. Section 6. When drawings take a back seat, prototyping and exploration. While engineering drawings are crucial for production-ready parts, there are situations where their level of detail might not be necessary. In the early stages of design, when exploring concepts and experimenting with different ideas, 3D printing can be incredibly liberating. For rapid prototyping and proof-of-concept models, the focus is often on form and fit rather than precise tolerances. In these cases, a 3D model might be sufficient to convey the basic design intent and allow for quick iterations. However, as the design progresses and moves closer to production, detailed drawings become indispensable. Section 7. The future of manufacturing, a symbiotic relationship. As technology continues to advance, 3D printing and other digital manufacturing methods will undoubtedly play an even larger role in the future of manufacturing. However, this doesn't mean the demise of engineering drawings. Instead, we're likely to see a symbiotic relationship emerge. 3D models will continue to evolve, potentially incorporating more of the information currently found in drawings. However, the need for clear, concise, and standardized communication in engineering will remain paramount. Drawings, in their various forms, will continue to serve as the foundation for precision, quality, and repeatability in manufacturing. Section 8. The power of precision drawings in the age of 3D printing. In the age of 3D printing and digital fabrication, it's easy to get caught up in the allure of virtual models and rapid prototyping. The ability to quickly create physical prototypes from digital designs has revolutionized the way we approach engineering and manufacturing. However, it's crucial to remember that 3D printing is just one tool in the engineer's toolbox. While it offers incredible flexibility and speed, it cannot replace the foundational elements of engineering. Detailed engineering drawings remain essential for translating design intent into functional, manufacturable parts. These drawings serve as the blueprint for precision and accuracy, ensuring that every component fits perfectly within the larger system. They provide the precision, clarity, and control needed for successful manufacturing. Without these detailed drawings, the risk of errors and miscommunication increases, potentially leading to costly mistakes and delays. As we embrace the possibilities of 3D printing and other advanced manufacturing technologies, let's not forget the power of a well-crafted engineering drawing. These drawings are not just technical documents, they are a testament to the engineer's skill and attention to detail. It's a testament to the enduring importance of precision, communication, and the fundamental principles of engineering. In a world where technology is constantly evolving, the core principles of engineering remain steadfast, guiding us towards innovation and excellence.